Let's start with exercise 1. So suppose you're working with a t-distribution, 40 degrees of freedom. You're given your test statistic, and the alternative hypothesis is that mu is greater than mu naught. So then would you reject or fail to reject the null hypothesis? So the point is you need to compute the probability. Let's do it like this. Let's say the probability that the t-distribution with 40 degrees of freedom is greater than your test statistic. I know it's greater than because I'm going off of this value. It's the same. When you plug this into the app, you're going to get approximately 0. You can actually predict this. This t-distribution is going to be extremely close to normal. And so, almost 6 standard deviations away from the mean is going to give you an extremely tiny p-value. And so the point is, whatever you get here is a lot smaller than this, so you should reject the null hypothesis. Okay? Okay, let's look at number 2. So we're given this information. We're asked to find a 95% confidence interval. The first thing we need to do is we need to compute t star. And so we hop over to the app, and you're going to put 95% in the red box. You're going to select the central area option. You're going to punch in 15 degrees of freedom, and when you do that, you're going to get t star is about 2.13. Other than that, you're just using the formula. So I take x bar 13.4 plus or minus my t star 2.13 times the standard deviation 2.12 divided by the square root of the sample size, which is 16. And so you plug everything in, and you'll get 13.4 plus or minus 1.129. Or if you want, you could also, actually break it up and go something like 12.271 out to 14.529. We'll do one more in this video, and then we'll break it. So we've got a simple random sample of size 200. Found that 144 of those students were satisfied with the quality of their calf food. So p hat is just 144 out of the total 200, which is 0.72. So that's that. The standard error for p hat, if you look back in your notes, we've got the formula for that. Let's write down the formula here just as a reminder. You're going to get p hat 1 minus p hat divide by n, and so the standard error is going to be equal to, I got 0.0318. So we'll just say equals 0.0318 when you plug everything in there. Okay, 99% confidence interval, so I'm using the formula p hat plus or minus z star times this guy right here. I'll just copy this. So we'll put that right there. So plug everything in, and you're going to get p hat is 0.72 plus or minus. You need to come up with z star. Actually, if you look in your formula sheet, I give you, I think, 90, 95, and 99, the z stars for those confidence levels. So you can either use the app or it's actually listed in your sheet. But the point is, you should get 2.576 times, we'll just, we know this computes to 0.0318, so we'll just multiply by 0.0318. And when you do that, you should get 0.72 plus or minus 0.0819, and so we'll call that good. The margin of error is just the second term here. Don't redo it, just recycle it. So the margin of error is m equals 0.0819. All right, that's the first page.